My name is Mina Arabi. I'm the editor of The National, based here in the UAE. And I have to tell you, my favorite part of the World Government Summit is the incredible ability to exchange ideas with Nobel laureates who are the greatest brains in our universe. So Professor Schmidt, he is an American-Australian astrophysicist who won the 2011 Nobel Prize in Physics for discovering accelerating expansion of the universe when many thought it was contracting. He's the 12th Vice Chancellor and President of the Australian National University and is based in Canberra. I want to start with the effects of the cuts that we're seeing in the sciences from governments, of course the United States, but also other governments around the world that traditionally funded the sciences.
Yeah, we're definitely seeing a cut that's very broad. You're seeing the UK, Australia, the US, throughout Europe. And it's significant because the buildup of scientific expertise, people, it's a human endeavor, and it takes decades to build up that capability, but it only takes a week to cut it. And so we're seeing cuts and a great loss of capacity across many of the strongest Western nations' science programs. And worldwide, though, if you're looking at China, China is doubling down. And so we're going to see a very large shift of scientific expertise to China, and that's baked in at this point, because the cuts that are happening now will have decades-long effect.
And are the effects mainly in terms of what will be funded, or is it about having the expertise and therefore ability to drive even the global economy?
Yeah, so we're losing all this expertise, and so the ability to generate ideas, so you can put money, but you got to have people to do it. And so in order to create scientific capability, you have to have scientific leaders who train graduate students, and so it does take time. You can't just turn it on as a switch. It has a decade-long turn on. And so, we have probably lost 20% of capacity, especially young people, across the different parts of the sector by what's happened. And that just doesn't come back quickly. It is a long-term effect.
And that long-term effect is also in the minds of politicians when they're making these decisions, because ultimately, scientific funding takes time. Certain things could be tried and failed. You have to experiment at a time when short-termism is often rewarded. So how do you make the balance? How do you convince a politician, or how does a politician convince his or her constituents that it's actually worth that long-term investment?
Yeah, so if you look at government expenditure, I think people understand defense is a long-term investment, that you have to think about that. And innovation in most places has been seen as that. It's something for the long-term national prosperity. And, a government that spends, let's say, 1% of its GDP, that's what Singapore does. May I say, the richest PPP place in the world at this point with zero natural resources. Maybe a correlation there. 1% is about as much as you would ever spend in this. So it's about getting people understanding is that it has long-term value, and that in the short term, yes, there are hard decisions have to be made, but if you take it from there, it's not going to be replaced by anything. It has a long-term effect, but it requires trust and understanding of the feedback loop of how ideas generate the knowledge, the people generate the ideas and knowledge that translate ultimately into prosperity as broadly defined.
Is 1% of GDP what you think governments should be spending on scientific discovery or sciences in general?
1%, it's hard to say you should probably spend more than 1%, but a 1% is, I would say, look at Singapore. It is a place that was dirt poor in 1957 and is the richest place per capita in the world at this point, based entirely from a technocracy investing in its human capital.
It feels like most of us are now looking to the private sector for technological advances, scientific discovery. Why can't we leave it to market forces? Why can't you leave it to the private sector?
Well, we do want to leave a lot to the market. The market is really good at taking ideas and then trying to translate them. And indeed, I would say the government sector, the university sector, it's pretty poor at that. Our people are good, but not within, for example, a government research lab or a university. You really need to have the market forces which can fail an idea really quickly or exponentially grow it quickly. And a university doesn't work that way. A government lab doesn't work that way. So you have the stock of ideas. This is, essentially a public good. It's a public good that needs to be freely available. So when a lab in China comes up with an idea, anyone in the world can use that idea to think about the next bit. That's how you get this great stock of knowledge, which then innovation systems, which are going to be based in the private sector, are going to be able to amplify into new ideas.
And that's also related to what is open source and what is proprietary, or who owns the IP. And so again, we're at the World Government Summits. When governments are thinking about this, how can they ensure that there is that spread of knowledge, information in the sciences that then allows for the innovation?
Yeah, so I'll take Singapore as a worked example. They go through and they say a third of our 1% is going to be basic bottom-up ideas. Companies aren't going to do it. They don't get to hold on to the IP, and it doesn't have that multiplication factor where everyone gets to use it. So they're going to dedicate it. But in terms of that open science, when government's paying for something, they should demand it's open. Everyone gets to use it, so you get to multiplier through the economy. The other 2/3, then you got to come up with an industry policy, a translation policy, and those are hard. If you're here in UAE, it's completely different than the United States, and it's not easy to do it in small countries. Easier to do it in the United States.
So if we think about mid-sized countries, we don't think of ourselves as small. Mid-sized countries, or countries that are newer, let's say, into the field of investing in the sciences and really wanting R&D to take off. Where do they start? What should be the priority?
Well, I think you really want to start a bottom-up group. You want to have a good, strong university system where you say, people come and just do things. And from that, you build a stock of knowledge and a stock of human capital who are capable of then taking an idea and running with it. I mean, you really need to have people who are connected globally, because it's not normally a single person does everything. They got to know person A who can do this, person B who can do that. They got to have friends who have access to this type of capital. So it's a really networked bit. And so being able to just create centers of excellence, like real excellence, and then build in the translation activities around that. It's not either or. It's you got to get that core excellence and then build translation around it. So the excellence comes first.
I want to shift gears because, again, you're an astrophysicist. There's a lot of interest in the cosmos and where does the universe take us next. But it's also the study of cosmology. What can it teach us at a time that we live in a world of uncertainty, where you need patience to understand how trends will unfold, and we live in a very fast-paced world?
So we look up to the sky. Everyone on Earth, can look to the sky. We share the skies as a commons. And astronomy turns out to be something we have shared throughout history. It is where the scientific method came through. In the 1840s, France and Germany were not working, but a French astronomer said, I think that there probably is a missing planet because I can see Uranus isn't going the right way. And a German astronomer found it. During the middle of World War I, Einstein and Eddington and people were talking about general relativity. In 1962, an Australian radio astronomer was invited to start a telescope that would look at the sun in China, and it was literally the first crack in Mao's door of Western connection. So it is something we can do together. We are allowed and able to work across pretty much any nation in astronomy. And so it is something that on its own does not have strategic value, but it has human value. So it's a good collective endeavor to do things. And even astronomy creates all these things that are in your mobile phone, such as your digital camera. That comes from astronomy. The Wi-Fi, that comes from astronomy.
So what next could be coming through from astronomy?
Ooh, that's always an interesting question. There's all sorts of stuff. So we have from the gravitational wave, we have 6 spinouts out of ANU alone. including being able to do remarkably accurate precision measurements of where you are using essentially squeezed light, which is a process we use to discover black holes merging. And so that's something that we produced. I'm on a startup that uses the processing of data that allows us to make new types of scientific instruments that are far more powerful and much cheaper than we ever before. And there's a whole bunch of other things like that. So it's a very long list.
It is a long list. But is that list going to change because AI is coming into full force? I think one of the things that really makes the Nobel Prize remarkable is it shows us human genius and what is possible. And often, your Nobel Prize came out of a collaboration, so it's that collaboration element also. But we're going into an era where artificial general intelligence is most likely going to happen in our lifetime. If you believe some of the predictions. But in all cases, there's a sense that AI will become smarter than us and able to solve all the problems in the world. So where does that leave the human endeavor?
Yeah, so, AI is, I'm not confident it's going to become a general intelligence anytime soon. I think we're a long ways away from that, but I could be wrong. What I think
you're right.
Yeah, but I think, our Nobel Prize, we used a very simple AI model back in 1994. But I see AI right now as this amazing tool that amplifies my abilities. No different than a computer amplifies my ability. A computer can add up things 1 billion times faster than I can. And it hasn't taken away my usefulness as a human. Now, as it gets more and more sophisticated, I guess the question is, being humans, who asks the questions? So imagine AI starts asking the questions and answering them. Well, as a human, does that make my life better? Let's think of a universe, or an Earth, where AI completely control everything. So is it going to babysit me? How is it going to treat me? There's a TV series on that is Pluribus, which is, I think, exploring this. And I think if you watch that, you will say, I actually don't want AI babysitting me and just treating me as, the thing it spends all its attention on. I think we need to, as humans, make sure it improves our lives. And the challenge we have with AI is that AI is really hard to get to do things well that are good and very easy to use poorly or to do bad things. And my big worry for AI is that it will be used to cause problems rather than to do good, because it's so much easier to do bad with it.
How do you make it do good? What do we need to do? Because there have been other tools and technologies. The nuclear technology and nuclear bombs are an example that often people cite, right? So what do you need to make sure that it does end up being used for good?
Very big challenge. At some level, I think there's going to have to, who's accountable for AI? So accountability is absolutely essential of AI when it's not going to be accountable to itself. You're not going to just unplug it. Someone has to be accountable. I think that's going to have to be a human. So when it's misbehaving, someone needs to be accountable. And if we do that, we have legal systems and things to actually deal with that. Right now, we're giving everyone a free ride and saying, if your AI goes out and kills someone, that's okay because it's AI. You cannot have a society without accountability. So assigning accountability, I think, is going to be essential.
What excites you about AI when it comes to scientific discovery?
Well, I can use it to do a whole bunch of stuff that I find really boring. So my ability to go through and get it to do what I would describe as the rote work, which always needed me, when I'm looking up, is that an interesting object or not? It can do that. And I don't have to spend my time going, that image, yes, that image, no. It does all that. And I can use it then to spend my time trying to answer the interesting questions, to ask more interesting questions. It accelerates, if used correctly, the scientific process, and that hopefully should bring prosperity. I'm not, at this point, worried about it becoming a crutch which replaces me. I am far more worried about it being used to suppress people, because I think it does have that ability for bad, where it can be used to essentially influence people en masse at scale in a way that we've really never seen before, and I haven't quite figured out how we're going to deal with that possibility.
As we're at the World Government Summit, are you looking to governments to manage that in AI, making sure that it doesn't become a way to suppress or have asymmetrical, as you were telling me earlier before our session, an asymmetrical impact on our lives?
Absolutely, but I think, governments are the ones who could most easily use this to suppress people. So we have to be aware of that. And it's about governments saying, this is where accountability lies. And at this point, I don't think we have figured that out. I think people are not accountable when AI does bad things right now.
Okay, on that note, I want to thank you so much, Professor Schmidt, for sharing your insights and ideas with that. Thank you all for attending.